Hi, welcome back. Here is an example of a typical SAT question which will test your knowledge on hyperbolas. We will come back to this question in a minute, but before we answer this question, I want to go ahead and review the hyperbolas. So let's get started. So the hyperbolas are shaped as shown here, where the transverse axis is actually running parallel to the x-axis. The transverse axis can also run parallel to the y-axis, which we will see in a minute. So what are the important parts of a hyperbola with the transverse axis running parallel to the x-axis? Well, there is the foci. There are two foci, and the foci is the distance from the center, which is the midpoint between the two vertices, to the focal point here. Then you have your two vertices, and you have your center, which is the midpoint between the two vertices. The center is designated as HK. Notice the rectangular box. The distance from the center to the edge of the box is designated letter A, and the distance from the center to the shorter edge is designated as letter B. Letter A is always the longer distance and B is always the shorter distance. So a rectangle can be created with this information with the distance of A and B. Now notice the asymptotes. The blue line here are the asymptote lines that are drawn through the center, and it goes through the corners of the rectangular box. Using these asymptotes as guidelines and the known vertices, you can actually sketch out a hyperbola. The general equation of the hyperbola with the transverse axis along or parallel to the x-axis is x minus h squared, and h is the x value of the coordinates of the center, divided by a squared, which is the length from the center to the edge of the rectangular box, minus y minus k squared, which is the y value of the center, squared, divided by b, which is the distance from the center to the other edge of the rectangular box, and that is all set equal to 1. Now the c value is the distance from the center all the way out to the focal point. C squared is equal to a squared plus b squared. So if you knew c and a, you can always calculate b, or vice versa. Now let's go ahead and look at the hyperbola where the transverse axis is along the y-axis. The difference here is that the equation is y minus k squared divided by a squared minus x minus h squared divided by b squared, which is again set equal to 1. I want you to notice that the positive here is the y term, whereas if the transverse axis is along the x-axis, then the positive term is the x. And notice that the longer distance, is below the y term as well. So you can see that the transverse axis is running parallel to the y-axis. Here's your foci, two focal points, and the distance from the center all the way to the focus is c. The distance from the center to the longer edge of the rectangular box is a, and the red one, the distance from the center to the other edge, is b. We use the same equation, c squared is equal to a squared plus b squared, to find our missing term. And the center again is hk. So let's go ahead and see how we can use this information to predict the equation of a hyperbola. Here's a question. Write the standard equation of the hyperbola with the foci -1, 1 and 5, 1, and the vertices 0, 1 and 4, 1. So again, I will sketch out my x and y axis, and I want to put my given points first, so I know that the foci is -1, 1, and here's 1 point here, and the other foci is 5, 1. The vertices are 0, 1, it's the red one here, and 4, 1. And I know that the foci has to be inside the hyperbola, so I know to sketch the hyperbola going this way. And that tells me that the transverse axis is parallel to the x-axis. So I will work with the general equation of x minus h squared divided by a squared minus y minus k squared divided by b squared is equal to 1. Knowing the distance between the vertices, which I know to be 4, so half the distance is 2. So the value of a is 2, h is 2, k is 1, that's the center right there, that's the midpoint between the two vertices. And the value of c is the distance from the center all the way out to the focal point. And I know the center starts from 2 and the focal point ends at 5, at least for this one here, so that the distance is going to be 3. And similarly, distance from here to this focal point is also 3. So the value of c is 3. I know a and I know c, so I can figure out what b is. It's c squared minus a squared, which is 9 minus 4, and b squared is 5. So I know b squared is 5, I know a squared is 4, and I know h is 2, which is what I put here, and I know k is 1, which is the y value of the center point here. And I'm done. That's the equation. I'd like you to pause the video now and try this on your own. Okay, the question was, write the standard equation of the hyperbola with the foci 3, negative 3, and 3, 7, and the vertices 3, negative 1, and 3, 5. So I'm going to show you the answers and see if you got that. So the equation is y minus 2 squared divided by 9 minus x minus 3 squared divided by 16 all equal to 1. And again, sketching the graph out and figuring out the distances is probably the easiest way to do this. You can pause the video and take some time and make sure you understand this. Pause the video, take a minute, and do this problem. Okay, so I want to show you the answer, and hopefully you got the answer. This one is not nearly as difficult as the ones we were working on. All you needed to do is complete the square and get your HK value of negative 2 and positive 3. So your answer should be B. This completes my video on the hyperbola. Thank you very much for listening. I shall see you again. Goodbye.